Here we're looking at the results of various Benedicts or Fehlings solution tests with various amounts of reducing sugars. Here we have no reducing sugar present, a traceable amount, which is very small, between 0.5% and 1%. We have a little bit. This is a low amount between 1 and 1.5%, up to 2%. And then finally up here we have the dark red color, and that tells me that we have more than 2% of a reducing sugar present. Now remember that monosaccharides are all reducing, some disaccharides are reducing, and most polysaccharides are not reducing. So let's go down here. These are what actual results look like. So this one has no reducing sugars. This one has a little bit of reducing sugars. You're starting to see a little bit of a yellow color coming in. Then it gets to an orange, not as quite as red. And then here we have the red, and that says that there's a large amount of reducing sugar present. So let's go down and let's see what happens when we see starch. Here's our starch. This is our amylose, which is our long unbranched chain of glucoses all joined together. And what's going to happen is we can break it apart here and we'll get a single glucose. And we do it here and here and here. And again, we get lots and lots of glucose. When we use amylase, it only gives us glucose. If we use heat and acid, we'll start to get some maltose, which means it's breaking off two sugars. So these two sugars would give us maltose. But in any case, either of those are both reducing sugars. So as we produce maltose or glucose, we will start to see some reducing sugars, and we'll start to see that red color showing up. And here we see the same thing happens with amylopectin, the branched chain form of starch. And so it'll turn into, again, glucose or maltose. If you're heating it with acid, it will produce some maltose. And these are the actual results that we see. So here's some starch with a very short period of heating. We don't see much color change. It is a little bit lighter than the original, but we can't see the original here. So we're going to just say it had very small change. And that's because there's no reducing sugar present in the starch. But here it is. After it's been hydrolyzed for about 80 minutes in acid, we start to see this dark red color because there is a lot more maltose and glucose there. If we continue to heat that for even longer, it might get even darker red. But you get the basic idea that as we hydrolyze the starch, it breaks into individual glucose molecules.